Hey everyone, and welcome again. In the last video we show how you can make this module, and in today's video we're gonna test it, well, the whole thing at the end, and we're gonna instantiate 4 of them to make the 4-bit multiplier. So the first thing we are gonna do is make a new project, and we're gonna call this boot top, and okay, next, finish. Let's add a new source and Verilog module again, boot top, and remember the inputs are gonna be M, it's 4-bit, and Q. This is also an input and it's 4 bits. Well, it's technically 5 bits, but the other bit we're gonna add it later. So just leave this like this because we're gonna have a 4-bit multiplier, so both inputs are gonna be 4 bits. And as let's put C as output, and if you remember we are gonna have an 8-bit output, so it's gonna be 7.0. The first thing we need to do is instantiate our previous module. To make sure we don't make any mistakes, we will open up the previous project. Open, here it is, boot, open, and it's called boot. So boot, and we will call this boot 1. Let's close this, and again the inputs and outputs with a dot. Okay, now that we have instantiated our module, we look at the picture again, and we see that M is gonna be just connected to M, Q to Q in, and a 4-bit number 0000 to A in. And so let's do this. And A in, it's gonna be a 4-bit number 0000. M is just M, and Q in is just Q. But remember that we did this 5 bits, so we have to add an extra bit in the next to the LSB. So let's do this, and it's gonna be Q, comma, 1 bit and 0. And again we look at the picture and we discover that in the outputs we have wires, so let's do this. Wire 3 to 0, and it's gonna be A out 1, and we will have 1 for Q, but this is gonna be 4 and this is gonna be Q. Sorry, A out 1 and Q out 1. So we have complete this, and let's copy this again to make another module. But now in the inputs we will not, now we're doing this. So in the inputs we will have M is the same in each module, but A in is the wire. So let's change that, and we'll erase this, and it's A out 1, and in Q in we will have Q out 1. So again we need another wires to do this. Now we just change the number, A out 2 and Q out 2, and do this until we finish. Okay, now that we have instantiated all 4 of them, and remember this has to be a different name each time you instantiate it, So in the last one we need to change to boot 4, and we only need to assign the output C. So let's do that. Assign C equals to, because it's gonna be composed of several parts, it's gonna be composed of out4 and qout4 4 down to 1. And okay, after you finish this, remember we need to add this module we did previously to this new module. So it's gonna be project, add source, and go to the inside boot with it, boot, open, okay, and now it is instantiated. Let's run this. Okay, after we check syntax, we see that we get this warning, but it doesn't matter, so ignore this, and it's finished. So let's test it and add in a source and Verilog test fixture, test, yeah, boot up, finish, and we will try this with simple numbers. MNQ, and let's add the delay. Let's put this 60 and copy. Let's multiply 4 times 3 and 7 times 7. Let's change this simulation, check syntax, and simulate. So let's look at this. Change this to sign decimal and sign decimal. So again, let's check this. 4 times 3 it's 12, and 7 times 7 it's 49. So this is really good. Again, this algorithm works for signed numbers, and that's it. So hope you find it useful, and we'll see you in the next video.